This video is on the objective understand the difference between correlation and causation. Right. So when we say that two variables have correlation, there is a correlation between two variables, that simply means that there is some sort of linear relationship between them. That, they could have a positive relationship where as one increases, the other increases. They could have a negative relationship where as one increases, the other decreases. But that doesn't mean that one causes the other to happen. Okay, so you're going to see that in this here, and this was mentioned in another video in some other objective, I'm sure, that correlation does not imply causation, right? Just because two variables are related, positively or negatively, that does not mean that one causes the other to happen. A lot more needs to be done to show that. Alright, so just showing that two variables have a linear correlation does not mean that they cause one another. Alright. So again, if you want to see their instruction, click on more instruction, but I'm going to go over it here with you as well. Alright, so causation. Causation is when one action or event causes another action to occur. For example, smoking causes lung cancer. That has been shown. And running causes weight loss. Well, running along with a lot of other factors, proper diet and all that, causes weight loss. But one action, one event causes another. Versus correlation. Correlation is a relationship between two actions, where one action does not necessarily cause the other. It could, but it doesn't mean it does. Right? For example, smoking and alcoholism are correlated in that a smoker is much more likely to be an alcoholic than a non-smoker. Now, this doesn't prove that smoking causes alcoholism. All right, it just, we're just saying they're related. But that, we're not saying that one causes the other to happen. They could both be caused by some other factor, such as high stress, or it could just be chance. Alright, so correlation versus causation. Statistical variables can also be correlated, as we've seen. We've been studying linear regression, linear correlation here in this assignment, this chapter. When two variables are correlated, right, that means a change in one variable is associated with a change in the other. There can be a positive or negative relationship, as I've mentioned. Right, with a positive relationship, an increase in one variable is associated with an increase in the other. With a negative relationship, an increase in one variable is associated with a decrease in the other. Correlation is easier to prove since it is a relation in the data that can be numerically measured using techniques such as, linear regression that we've been seeing. Causation will also cause a relation between the dependent and independent variables, right? So if you have causation, right, if one variable causes another to happen, there will be correlation. All right, so causation does imply correlation, but not the other way around. Correlation does not imply causation. But it is much harder to prove causation because it requires showing that one caused the other. There's more, and they get into some guidelines as to how do you legitimately show that one variable caused another to happen. So simply showing that one event follows another, or that two events occur together, does not prove causation. it takes a more in-depth and sophisticated experiment or study to prove causation. So any causation will result in a correlation, as I've said. But most or almost all correlations do not imply a causation. So an example of correlation that was thought to be a causation is the idea that bad odors cause disease. The two often appear together, so it is easy to incorrectly assume that one causes the other. However, germs cause both. Right? Germs cause the bad odor and the disease. So it wasn't the bad odor that caused disease. Right? The incorrect theory, that the bad odor caused disease, seemed reasonable because cleaning up the bad odors did reduce disease, but it was actually cleaning up the germs that reduced both. Note that this is incorrect causation. Right? Note that this incorrect causation can still be seen in the nomenclature, or the way that they name things, of the disease, malaria, which literally means bad air in Italian. Okay, so here, right there, you can show that bad odor and, disease are correlated, but one does not cause the other. Right? The germs cause both of them. So you gotta be careful. So when it comes to showing causation, right, to actually showing that one event causes another, the Surgeon General of the U.S., and I'm sure other countries, and maybe the World Health Organization, whatever, provides guidelines for proving causation in a medical study. The list below shows that finding a correlation is the first step, but there are many others before causation can be proven. Alright, so number one, is there a strong relationship between the variables? If so, then we got a lot of other things to show, a lot of other things that need to happen before we can actually say that one caused the other. Is the research design strong? Right? Is the experiment well designed? A time relationship, a temporal relationship, a cause and effect relationship. The cause must precede the effect, right? One thing, in order for one thing to cause another, it must happen before the other thing, right? Dose-response relationship, higher exposure leads to a higher proportion of people affected. Reverse association, right? Removal of this cause reduces the incidence of the effect. Consistency. Multiple studies in different locations produce the same effects or similar effects. Biological plausibility, right? There is supportable biological mechanism for why this is happening. And coherence with known facts, does it jibe with other things we know to be true? So just showing that two variables are related in some way doesn't come near showing that one causes the other. So their first example here is, true or false, increases in height cause increases in shoe size. Cause. Now they may be related, You might think, yeah, an increase in height is associated with an increase in shoe size, right? Usually taller people have larger feet. But that does not mean that one causes the other to happen. As they describe down here, there may be other outside factors that increase shoe size as well. Hormonal imbalances, changes in, mostly chemical makeup of your body. And you can increase height, without increasing shoe size. That happens to many people. With either surgery or, again, some sort of hormone treatment, or it just happens sometimes. People grow taller and their shoe size doesn't increase all that much. So yes, there's a relationship between them. One increases, the other increases. Seems like there's a positive correlation between height and shoe size, but that does not mean that an increase in one causes an increase in the other. So this is a false statement. Saying that increases in height cause an increase in shoe size would be false. And they explain down here. Alright, so let's get to the problem at hand. So this is more, there's not really a lot of numbers involved in this objective, it's just a lot of reasoning. All right. So suppose that a large controlled experiment tests whether caffeine improves reaction times. A very large number of randomly selected participants are randomly given identical seeming pills with varying doses of caffeine, including some people who get no caffeine in their pills, and then given tests of reaction times under the same conditions. The experiment finds a strong negative correlation between caffeine dose and reaction time, meaning the following, right? Remember what that means. If I'm drawing a scatter plot where on the horizontal axis, say I have a caffeine dose, and then on the vertical axis, say we have reaction time. So what they're saying when they say they have a strong negative correlation means this. You know, if I plotted a bunch of points, maybe I took a bunch of people, right? It means that these data points are tending downward, right? They're tending downward. And if I were to draw some sort of best fitting line here, that line would have a negative slope, right? They're tending downward. As the caffeine doses increase, the reaction times decrease. You know, they get better, according to what these people saw in their study. All right, so there's a negative, right? There is a strong negative correlation between caffeine dose and reaction time. So identify what can be concluded based on this information. Well, can we say that there is evidence that caffeine causes lower reaction times? I wouldn't say that. This is just one study. A large study, sure, but it's only one. There's not the multiple studies with similar results in different areas. You know, and then they don't do the lots of other things that need to be done to show causation. Now, I might say this because of the whole large controlled experiment thing, but let's keep that on the back burner for now. I'm going to say no. Here, people with lower reaction times generally choose to consume more caffeine. No, that's not what's being said here at all. Lower reaction times are associated with higher caffeine doses. That is what's being said here. There's a strong correlation, negative correlation, between caffeine dose and reaction time. But this study provides no evidence that caffeine causes lower reaction times, right? There's got to be more. Just having an experiment find this strong negative correlation doesn't mean that one causes the other. Okay, so I'm going to say this for now and see what happens. And then there is no relationship. Well, no, they told us that there's a strong negative correlation. Oh. So what happened here? Probably because of the controlled experiment. Yeah, yes. Alright, it is an appropriately randomized controlled experiment. Okay. So like I said, I was keeping that one on the back burner. I guess that was enough to say it was large and controlled. Yeah, because I guess if you think about it, they did kind of do a lot of the things that would prove it caused, you know, the high caffeine caused lower reaction times. You know, they took it away. You know, some people had no pills and they saw that maybe those people, you know, no caffeine corresponded to higher reaction times. So they had different levels of caffeine. That was pretty good. Again, it's a controlled experiment, so it's a well-formed experiment, a well-structured experiment. It looks like, and I guess because it's large, you know, you could say it was done multiple. You know, it was large enough to where we could say this causation stuff. So it's more than just that. All right. See? So this one, even I can get this wrong. So you gotta be careful. So I guess if they mention anything about it being a controlled experiment, the research is sound, and the way they form the experiment is sound, and they control the amount of caffeine and all that, and then find the correlation as well, you can probably say that one causes the other. Alright, so my apologies there. Let me actually continue on and do another question. Let's get one right. Alright, so here, understand the same objective. Alright, so true or false, the more samples taken in a scientific study, the longer the amount of time it will take to complete the research on the samples. Now, are they talking about the amount of research in each sample or all total? If you take more samples, it should take you longer to complete the study. Yeah, I mean, that makes sense, right? If you take more samples, it'll take you more time to finish your research. Now, although there are other factors that affect study time, such as experience and equipment, increasing the number of samples will cause an increase in research time. I mean, that. Some of these are look seemingly common sense, and some are not so much like the previous one. I guess again, if they mention that it's a controlled experiment and they vary the levels of one variable and determine that there's some sort of correlation, I guess if they're doing more than just showing the correlation, then they'll be showing causation. Alright, so that's a bit iffy. I apologize for that, my error earlier. Hopefully you learned from my mistake, and this video and the more instruction and reading the answer explanations. I'm hoping all this stuff helps you out when you work on this material on your own. And I will also have another video on this where I do another problem. And again, hopefully all this put together, learning from my mistakes and all that, all the more instruction, the answer explanations. Hopefully this will all help when you work on it on your own. Right, and thank you for watching.